Hello everyone, I am Bigfoot and I am a structural engineer. I mean, I do other things as well, but primarily I do structural engineering. That's what I do as a day job, and I'm constantly on the lookout for interesting stuff happening with structures. It doesn't happen very often, but mainly not necessarily to make YouTube content, but just because I have a weird fascination with people who do my job and potentially get it wrong. And this structure passed across my nose last couple of days, so let's have a chat about it. Probably the best way to introduce it is to go through a news article. I watched a couple yesterday. This is probably the best 2 minutes or so video that I found.
This morning, the rush to stabilize a building under construction in Midtown Manhattan after support columns buckled, sparking fears of a catastrophic collapse.
We have columns partially down on 21 and 22. And we have floors sagging between 21 and 26.
The first call came just before 8 a.m. Tuesday for bricks falling from the building.
Okay, so we've got buckled columns and we've got floors that aren't level anymore. We've got one of those buckled columns in the shot. I think there is another one. I don't quite know whether it's in here or not, or being obscured by something else. And it's really quite obvious that the floor above is sagging. Now, when it comes to structures like this, if it's visible, if you can see it with your naked eye, it's a big problem. When we're generally measuring movements of buildings, we have to use very precise, very, specific equipment to make sure we know where it is. And we're talking fractions. So you can't even perceive it to the naked eye. So the moment it is perceptible, it's a problem.
Workmen noticed the buckled columns, multiple cracks, and the floors beginning to sag. This video, obtained by ABC News, shows some of the warped metal.
We have some 40-year members on that job who have never seen an I-beam bend in half.
That's not supposed to happen.
No, that's not supposed to happen.
Construction workers evacuated, then neighboring buildings, including 2 hotels, offices, and a school, emptied. Streets around the building shut down, bumper-to-bumper traffic stretched for blocks. For a time, the compromised building appeared to lean.
The way this building is constructed, it's a steel frame building, so it would not be a total collapse. It would be more of a localized collapse, but that remains our concern, that it's moving.
Now, I would take what that fireman just said with a very, very heavy pinch of salt. Once one of these buildings lets go, there really is no telling what damage it could cause. He's suggesting that in general, steel buildings, a small localized collapse, a small failure in a structural member will result in a small structural collapse. But that's a generalized statement. It's not based on anything that anyone can prove at this moment. We design buildings to be in equilibrium, and once they exit outside of that equilibrium, there is no maths that can conjure what will happen. And if we're talking about a lot of mass, which is what it looks like we are talking about, then that mass has stored energy at height. It can not only take these buildings out, it could do all sorts of damage to other things around it. He's a fireman. We've got to take it with a pinch of salt.
The building, formerly the headquarters of the pharmaceutical giant Pfizer, is being converted into apartments. It's the largest such conversion in city history. The developer said the columns likely bent under the weight of additional floors added to the East Side high-rise.
Once the immediate stabilization occurs, they have to look at the other columns around it and see if they're prone to the same thing happening. They're probably going to shore more than just the failed column. They should shore everything above to the best they can. It's easier said than done. This is a very tricky situation.
In the last year, the building has logged 7 violations, from unsafe building demolition to debris falling from high heights, resulting in more than $32,000 in fines. Overnight, workmen installed new steel columns and expressed confidence the building is no longer at risk of imminent collapse, but it is not yet fully stable, Robin. Once it is, they'll determine how those columns failed and a long-term fix.
Yeah,
Robin?
A lot of people want answers to that. You're right about that. Aaron, thank you.
Now, as of this moment, the building has been shored up, and it would appear like there is no imminent danger of the building collapsing. Now, I'm surprised by that fact, because you couldn't have paid me love nor money to walk into that building with those columns buckled that way. There's no way. I mean, they're gonna talk about all sorts of facts, like the building has stopped moving. We can't detect movement or what slope or pitch or anything. But You know, you can rest an entire building on a single bolt, and a single breath of fresh air will bust that bolt. You know, whilst it's resting on that bolt, it will be precariously balanced. It might not necessarily be moving, but that breath of fresh air, the bolt goes and gone. You know, the building. Just the fact that it's not moving is not enough evidence for my liking. Knowing enough about structures as I do. So it looks like the building is okay for the moment. Now, going forwards, in terms of blame, no one is really going to be able to tell who is to blame here. Not for a very, very long time. No one is going to stick their hand up and say, I did this thing wrong. There's going to be fingers pointing. There's going to be lawsuits. There's going to be all sorts. It's going to take a very, very long time for anyone to come up with a specific report that says one way or the other. And my immediate reaction was to just jump on the engineer, because that's just that's my speciality. That's my specialism. That's what I know. Maybe it speaks to my arrogance, but I've since been watching and reading a lot, and it's eminently possible that the engineer has specified that these specific columns that have buckled were meant to be strengthened or reinforced in some way, and that the contractor, the builder who was carrying out the works, just decided not to do that, or to sequence it in a wrong way. Just completely ignore. In terms of blame, no one knows, and no one is going to be able to tell. It would all be speculation. Now, in terms of what actually went wrong, regardless of the who's and the what's, let's have a chat about maybe what actually went wrong. All right, so I'm struggling big time in terms of trying to locate proper pictures of this, because I'm in the UK. This building is in New York. I can't just go and wander around. I mean, and the whole thing has been evacuated, so I wouldn't be able to anyway. But Street View and Google Maps is really all I have, and whatever shots I'm able to get from the news. So I'm really struggling to precisely locate where this is on the corner of the building. But I don't think it matters too much. Like what it looks like to me is that we have two different structures here. We've got this line, and then we've got the old structure that's below it, and then we've got the new structure that's above it, and then this slab here. This would be what we call in the trade a transfer slab. So this is transfer structure. It doesn't necessarily have to be a slab made of concrete. It can be made of steel. Just a transfer structure, and that transfer structure is taking the loads that's from above it, and it's transferring it back into the same sort of column dimensions that we had in the existing structure. That's what it looks like to me. I've tried to find pictures to confirm what was new and what old, and I can't quite find it. This is the best assumption that I can make. And you know what? It makes logical sense. So, I mean, when we're designing a big building like this, the load adds up as we go down the structure. The top column only needs to support a little bit of roof load, and then the next column down has to support that column which is supporting the roof load, but that next column down also has to support a bit of floor, and then the next column down has to support all of that stuff that's above it, plus a bit more floor. So as we work our way down the structure, the columns need to take bigger and bigger loads. And the top floor column, by empirical judgment, what I'm just saying, is that the top floor is the weakest one. It's only supporting a bit of roof load. And a lot of the load that we are trying to design for in these structures is associated with floors. Here in the UK, we just allow for 2 feet of snow on a roof. And the load that we would have associated with an office building would be about 4 times that. So, the top floor column, just supporting a very, very minuscule amount of roof, is going to be the weakest element. So, from an engineering perspective, these are the ones that would need to be strengthened, most obviously. As we work our way down through the building, the columns will get stronger. There'll be more and more meat from the original design still left in them, but the ones at the top will be most vulnerable, and that's what's happened here. We've overloaded them and they've buckled. It's happened now. That's just the result. That's just the way that it is. Now we're kind of stuck in the situation where we have to deal with it. And as I said, they've propped it up. They've prevented it from moving any further. But really, that's only half of the problem, because the building has moved significantly, and you can't just level it out. It's the whole structure is the way that the structural loads have been distributed through this building are changed. There's probably some steelwork beams and whatnot that have moved because the entire weight of the structure above it is now sitting on it, and those beams are now bent and moved and deflected. And there is no way to bend those beams back. You know, if we were trying to bend those beams back, we would have to exert not only the full weight that put it there in the first place, which is the weight of the building above it, just to overcome the weight that is above it, but we'd then have to exert the same force again to put it back where it came from. There's just no way that that's going to happen with a building of this nature. The only realistic outcome that I can see is that the building above, the new part, is taken apart bit by bit as carefully as they can, because I don't see any value in it ever. The floors are always going to be, you're never going to be able to get it back square again. This is it now. So it's still very early days. And the building obviously hasn't collapsed yet, and it looks like it's going to be fine. But there are long-term problems going forward, so I guess we'll see what happens. But I don't think we'll hear about it. I think these things will just happen in the dark, in the background, because the people who are paying for it to be put right, they're going to be taking a certain amount of liability, or maybe it's been taken out of their hands. Maybe a whole new crew has been. I mean, that's the proper way that it should be done. Really what should be happening now is that the developer and the construction team should be taken off it. The engineer the original engineer who looked at it, who designed all of this stuff, they should be removed from it, and a whole new team should be brought in who isn't attached to those previous decisions. That's the right way that it should be played. Maybe I don't know how it works in America. Maybe the government steps in, or the mayor. I don't know how it is. We'll see how it pans out. That's all I've got.